everyone. Welcome back to yet another one of X Geeks live streams. I am super happy to be here with you all. And it's so hard to believe that we are closing in at the end of the year. 2023 went back super fast. Only 1 month to go in the in the year. I'm amazed. So everyone, if you haven't met me before, I'm Beatrice and I'm part of the X6 team. If you haven't heard about us before, then we represent what we believe to be the balance between product and project. Our expertise is around cloud native acceleration by unlocking agility and innovation in hybrid and multi-cloud projects. You can, of course, check out our social media for more information. And don't forget to follow us if you are interested in also more content from us. We are super, super excited to also share that with you. And without further ado, because as always, you are not here to listen to me listen to me ramble about things. I would like to invite to the stage Grace. They'll be joining us today and talk a little bit about effective observability in cloud native applications, right? Hi, Grace.
Hi, nice to join you guys. Thanks for having me.
Awesome. Thank you very much for joining us. Grace, I'll leave the stage to you. Please be sure, as always and as usual, to just do your amazing thing. Thank you.
Fab, thanks so much. Let me start sharing my screen. Hopefully we can get that up. Fantastic. Thanks, guys, for joining me. I know it might be late in the day for many of you, especially in mainland Europe area. So really appreciate your time to join this today. So yeah, my name is Grace Jansen. Lovely to meet you all. I'm a developer advocate at IBM, mostly working with sort of Java-based technologies like microprofile, Tcart-E, and OpenTelemetry, which we'll see some of later in this presentation. I actually did a biology degree before going to be a developer, work in software development. So if you're interested in that weird and roundabout journey into tech, then I'm happy to discuss that at any point, sort of through Twitter or whatever it might be. Talking of Twitter, if I don't get around to any questions that you have at the end, or if you don't want to ask them on this platform and you'd like to instead wait and ask them on a different platform that's, say, more private, then feel free to reach out through Twitter or LinkedIn. My Twitter handle is up on the screen here and will also be on the last slide as well. So feel free to connect with me there. So without further ado, let's get started with going through this looking glass and looking at how we can enable effective observability for our cloud-native applications. So why have I named this presentation Through the Looking Glass? Where does this phrase come from and why does it relate at all to cloud-native applications? You might be familiar with this phrase, coming originally from Lewis Carroll's book, which was a sequel to the Alice in Wonderland original novel. In this story, Alice passes through essentially what is a mirror, so looking glass just being the old-fashioned word for that mirror, over a fireplace, and finds herself once more in this enchanted land of Wonderland. So really, this phrase of going through the looking glass, which is what Alice was doing, is a metaphor that's used by Lewis Carroll. And it's a metaphor that's used sort of for any time that the world suddenly appears unfamiliar, as if almost like our world has been turned upside down. So similar to looking out from inside the mirror to find a world that's both recognizable, but kind of turned inside out on itself. So it kind of acts as this like portal or gateway to this magical world. And this is an analogy that's not just been used in Alice in Wonderland and that literature, it's used in other media as well. So for those of you who aren't literacy nerds, you might recognize this movie, maybe not from the still, but maybe from the GIF. So yeah, this is The Matrix. You might be more familiar with this one. So this isn't the only this film has lots of references back to that original analogy in Alice in Wonderland. There's a few specific references in it. So for example, in the beginning of the movie, Neo gets woken up by his computer, sending him a direct message instructing him to follow the white rabbit, the lady with the white rabbit tattoo. They also say, if you take the blue pill, the story ends, you wake up in your bed and believe whatever you want to believe. You take the red pill and you stay in Wonderland, and I show you how deep the rabbit hole goes. So all those references back to that original story of taking a step through this portal, entering this world that seems a little bit unfamiliar, a little bit higgledy-piggledy, upside down, and seeing things in a different way. And it's that kind of portal that we're trying to create into what can be quite a convoluted and complex world of distributed cloud-native applications. So we're trying to create this pane of glass that we can step through to be able to effectively observe and see what's happening to our application when it's deployed in the cloud. And so that's why I've named this presentation Through the Looking Glass, because we're trying to take that same step to see what we can't see at the moment necessarily very well, which is this new and unfamiliar world of cloud native. So why are we trying to take this step into the world of cloud native? Why are we trying to enable our applications to be effective in this environment? And I think it comes down to this reason, this excitement we get. Hopefully you guys are familiar with Toy Story. As you can see, I love Disney movies. Do go watch it if you've not seen it before. Great movie. It's this excitement we get of, ooh, the cloud. As developers, we get excited about it because it enables innovation and key characteristics and behaviors that we wouldn't necessarily get or wouldn't get as easily on other infrastructure. So things like portability, flexibility, resiliency, sort of fashion in terms of the innovation and the innovative technologies we're able to pick up and easily utilize in our own applications. So it's this excitement that drives us to want to create applications that work well in this environment. But it doesn't always feel like this. We don't always feel excited and happy when we're developing cloud native applications. Often we can feel a bit more like this. It can be frustrating. We can get that feeling and that experience of, well, it works on my machine. Why is it not working in this container? So it can be a very frustrating process and also frustrating for us to be able to understand what's going on in that environment. Because when we're creating applications that are distributed and being deployed to different cloud platforms, for example, in different environments, it can be very difficult for us to understand what's going on in real time to our application and be able to fix potential issues or bottlenecks that are occurring. So it's important that we enable observability to be able to give us that portal in to better understand what's going on, to reduce some of these frustrations and complexities. So that's what we're going to focus on in this presentation. We're going to be looking at how can we build that looking glass? How can we build that portal so that we can effectively understand what's going on with our application? So to do that, we're going to take a look at what we mean by this term observability. We're going to take a look at how we can enable this in our own applications through things like OpenTelemetry and microprofiles telemetry as well. And then we're going to take a quick look at a live demo. And this is one that you guys can try at home as well. It's utilizing a cloud native environment. So all you need is a browser. So if you'd like to check it out afterwards, I do encourage you to do so. We'd love it if you did. And then we're going to go through just a quick summary and give you some resources to check out afterwards if you're interested. So first things first, let's define what we mean by observability so that we make sure that we're all on the same page here and understand really what we're trying to achieve through the use of these tools. So observability, I took a look at a few different definitions, and I think there's various different levels at which you can define something like this because it's quite a broad term. So in general, what do we mean by this? Observability in general is the extent to which we can understand the internal state of something based only on external outputs. So really utilizing the external outputs to understand what's going on in what might be quite a complex system internally. So it's kind of providing these highly granular insights into the behavior of this system, hopefully with some rich context in there so we understand why that's happening as well. When it comes to IT specifically and cloud computing, I think we can get a bit more specific than that. Really, what we mean by observability is the ability to be able to aggregate, correlate, and analyze a steady stream of performance data to be able to effectively monitor, troubleshoot, and debug the application and the network. So it's these key three elements on either side. So on the data collection side, the aggregation, the correlation, and the analyzing, and enabling us to monitor, troubleshoot, and debug our applications and our infrastructure. So really, this is all about sort of this term observability comes from control theory. It's an area of engineering concerned with automating the control of a dynamic system. So for example, water through a pipe, for example, or the speed of an automotive over inclines and declines. It's all based on feedback back from that system. So we're all constantly asking, okay, based on the feedback we're getting, understanding what's going on within that system to be able to control and change it. So that's where these sort of key phrases and key elements are coming from. Okay, so now that we have this definition and we understand that we're trying to aggregate, correlate, analyze, to monitor, troubleshoot, debug, how can we actually do this within our own applications? So when it comes to the theory, so overall, Implementing observability is actually fairly conceptually simple. To enable observability in our projects, we just have 3 steps. The first of those is instrumentation. So we need to instrument our systems and our applications to be able to collect relevant data. And that might be metrics, it might be traces, it might be logs, it might be other metrics and data. And then once we have that being produced from our system and our applications, we then need to send that data somewhere. Step 2. We have to send it to some sort of external system that can then store and analyze it. You might be using various different exporters for this. So you might be using something like Jaeger or Zipkin or a different collector, for example. And these can all enable us to have this storing and analyzing. And then step 3, providing visualizations and insights into systems as a whole. It's all well and good producing the data firstly, and then collecting the data. But if we don't understand that data, we aren't going to glean many insights or be able to actually act on that data very effectively. So these visualizations and insights are really where we gain critical understanding of what's going on in our applications. And for this final step, you might be using tools, for example, like Prometheus, which is sort of a systems monitoring and alerting toolkit. You might be using Grafana, that's around like analytics, and it involves interactive visualizations, or Kibana, which is another tool you can use for exploring, visualizing, and building dashboards on top of the data that you're collecting. So these 3 tools can be really helpful for this. In this presentation, we're just going to be focusing on step 1. I said theoretically it's relatively conceptually simple. That doesn't mean that it doesn't take a lot of work to be able to implement this within your own applications. We still need to go through each one, and given the time today, we're just going to be focusing on this first step, which is that instrumentation part. I mentioned a few tools like Prometheus, Grafana, Kibana, Jaeger, Zipkin that can be used for steps 2 and 3. And in our demo later, I'll showcase how we're already utilizing one of those to add on top and achieve steps 2 and 3. But right now, we're just going to be focusing on step 1. So how do we enable instrumentation? So this is kind of the first step in making our system observable. What do we mean by instrumentation? This kind of means that our code should be emitting things like traces and metrics and logs, key data that allows us to be able to observe what's going on within our application. Logs, metrics, and distributed traces are often known as the 3 pillars of observability, hence this diagram. While plainly having access to logs, metrics, and traces, it doesn't necessarily make our system more observable, but these are very powerful tools that, if we understand them very well, can help us to unlock the ability to build better systems and to be able to tackle potential bottlenecks and issues within our applications. Now, that's not to say these are the only metrics we can collect. So, for example, there are additional metrics out there that it is hoped that in the future they're going to be integrated into some of the open source standards I'm going to go on to in a bit later. Things like, for example, end user monitoring. So being able to gain real-time visibility into the user experience by tracking the path of a single request and gaining insights into every interaction it has with each service along the way. So it can be achieved through things like recording an actual user using your application or synthetic monitoring, but this can be really interesting data to take a look at. There's also profiling. Profiling offers us a way to understand where our code spends its time and sort of which hardware resources it's using. Might be memory, CPU, when does it consume this down to the individual line number. So getting this real detailed analysis on what our code is doing, what it's utilizing in terms of resources, and why it's spending time there to try and make it more effective and efficient. At the moment, these 2, end user monitoring and profiling, are not included in the standards we're going to go on to. So today, we're just going to focus on logs, metrics, and distributed traces. But it is hoped that in time, things like OpenTelemetry, which we'll go on to, will also include other types of telemetry data like these 2 examples. So let's start with the first of these pillars, logs. So logs, I'm not going to spend too much time on this slide because a lot of you will already be utilizing logs. They are found almost everywhere in software and have been heavily relied upon by developers and operators to help understand system behavior for many years. Unfortunately, though, logs aren't extremely useful for tracking code execution because they often lack the contextual information that we need. So, for example, where were they called from? So they become a lot more useful to us when they're included with other data, included in things like traces, which we'll get onto. So logs are sort of essentially a fairly basic form of providing that higher level information about system behavior. It might be an error, it might be a warning, for example, but they're not necessarily associated with any particular user or any particular transaction or request. So they don't provide us as much contextual information. So they do have their shortcomings, but they are still helpful. In fact, in terms of how do we utilize logs, many runtimes, for example, and toolkits and platforms offer logging components as standard within them. So for example, OpenTelemetry, which is what we're going to be utilizing in our demo. This is a cloud native runtime, very modular, lightweight in nature, really designed for cloud native Java. It's on my t-shirt, and you can see the logo on the screen here. We'll take a look at it in a bit more detail later, but OpenTelemetry has a unified logging component that enables us to handle messages that are written by the application in the runtime, and it provides things like first failure data capture capability. So enabling us to utilize sort of that capability for logging in our applications. So that's logs, but as I said, there are some shortcomings with it. So we can't just solely rely on logs. The next pillar in our diagram that we had was metrics. So metrics are really more about sort of the numeric data. So it's about data over time. So it enables us to be able to have data that's more malleable to mathematical and probabilistic and statistical transformations. So being able to do things like sampling, aggregation, summarization, and correlation of our application's behavior over time. These make them much better metrics for us to utilize to report the overall health of a system, rather than just at a point in time, a potential issue occurring, for example. Those metrics can include things like system error rate, CPU utilization, request rate. Really, there's a wide plethora of different data that we can collect in metrics. But they can be really helpful, especially for things like triggering alerts or running queries against them. In terms of how do we enable metrics, there are various different sort of frameworks and libraries that you can make use of, one of which is MicroProfile. So if you've not come across MicroProfile before, this is a fantastic open source, really community-driven specification that was created to enable those using Java EE and Jakarta EE to more effectively create cloud-native microservice-based applications. So it offers various different APIs that you can utilize that are more designed for the world of cloud-native. So you'll notice the bottom row here, these are some of the APIs that come as standard with MicroProfile. You'll notice a lot of the bottom here is actually shared with Jakarta EE. So if you're already familiar with this other specification, you'll recognize a few of these. And that's because the two specifications work very closely together to enable sort of the innovation and progression within the Java space. So things like, for example, JAX-RS, JSON-B, JSON-C, CDI, it's actually CDI Lite in MicroProfile. All of these are offered within Jakarta EE, and then there are additional on top. And one of which I want to draw your attention to for this is MicroProfile Metrics, which you can see in the top right-hand corner there, which is one of the APIs offered to enable that observability within our applications. Do go and check out microprofile.io. It's the website where you can find out more information on this specification. Do bear in mind that this is just a specification, so you will need an implementation, a compatible implementation, to be able to actually make use of any of these. But luckily, the nice thing about this is because it's an open source standard that's developed by lots of different individuals and vendors, there are lots of choice when it comes to picking a compatible implementation. So for example, you can see OpenTelemetry up there, but you could just as easily utilize things like Quarkus, Wildfire, Pyara, whatever it might be. There's lots of flexibility and choice, so you don't have that vendor lock-in that you might have with other toolkits or frameworks. So as I said, MicroProfile Metrics is one of the APIs offered within this specification, and it can be a really helpful API to use if you want to enable that monitoring data, those metrics within your application. So I definitely suggest checking that out. We do have a guide, so like a live tutorial that you can check out on MicroProfile Metrics if you do want to see it at the end. I can show you where that is. But the thing about metrics as well as logs is that with both application logs and application metrics, they are system scoped. So it makes it quite hard to understand anything else other than what's happening inside a particular system. With logs without fancy joins, a single line doesn't give much information about what happened to a request across all components of a system. So really, this is why distributed tracing is needed on top of this to go beyond just that system scoped, to be able to tell us what's happening across the various different systems. And so that's why we have this third pillar, which is tracing, distributed tracing. This is really a monitoring technique that links the operations and requests occurring between multiple services. So it allows us to be able to trace, hence the name, trace the path of an end-to-end request as it moves from one service to another, letting us pinpoint errors or performance bottlenecks in the individual services that might be negatively affecting the whole overall system. Without tracing, it can be quite challenging to be able to actually pinpoint the cause of performance problems in our distributed cloud native systems. So it really helps us to improve the visibility of an application's health and enables debugging behavior that otherwise can be quite difficult to reproduce locally. So really, this is why we need this on top of just metrics and logging. And this might be something that you may or may not already have within your application, but often we have logs and metrics, but we don't yet have traces. So in order to enable tracing, we have some key concepts that we need to be familiar with. There's 3 key definitions, I think, that are needed to understand. So one is traces. So what do we mean by traces? This is just representative of the requests, and it usually consists of multiple spans. So really a trace is just the end-to-end journey of one or more connected spans, and it's normally considered to be distributed if the spans are performed on multiple services. So because we're in a distributed environment with often microservices that are distributed within our cloud platforms in cloud native, most of the tracing that happens is distributed in nature. Spans. What are spans? As we learned, spans make up traces. As you can see in my diagram here, I have that one trace at the bottom, and then I've got multiple spans occurring in each microservice here. So a span really describes an operation or work that might be taking place on a service. They can describe very broad operations. So it could be a web server responding to a HTTP request, or it could be as granular and small as a single invocation of a function. So there's a wide variety of different operations that can be considered a span. But essentially they contain basic information like name, time-related data, log messages, and metadata that allows us to understand what's occurring during a transaction at each stage. So you can see here how we've got multiple spans all leading into that trace on distributed microservices. And the key part here is that we also have context when it comes to tracing. So far we've looked at the components of a trace, but we haven't described how those components are all linked together. And this is where context is really important. So context is this immutable object that's normally contained within the span data that allows us to be able to identify the unique request that starts each span and that each span is a part of. So this data is required for moving trace information across service boundaries. What it allows us to do is just follow that single request through what can be a very complex distributed system. Normally, a trace context has 2 values. One is the trace ID or trace identifier, which you can see in the diagram here. We have some examples. And that is the unique identifier that's generated in the root span intended to identify the entirety of the trace. So it's shared throughout that trace by all the spans involved so that we can track which spans are a part of which trace. Then we've got the parent identifier. That's the second component. And this is the span ID of the parent span that spawned the current operation. A lot of spans in that sentence. But essentially what it means is that we can track back and work out, okay, what was the current operation and where did it come from? Where did that one come from? And what this allows us to do is with these 2 values, for any given operation, we're able to determine the originating root service and reconstruct all parent and ancestor services in order that led to the current operation. So this is really how we're able to determine and really pinpoint down those potential issues and bottlenecks within our application by having this context and sort of this specific nature of being able to trace all the way back in order. So now that we've seen theoretically how we enable tracing, how do we actually go about enabling it in our applications? And this is where we turn to open source standards like OpenTelemetry. So in the past, the way in which code was instrumented would vary dramatically because each observability backend would have its own instrumentation libraries and agents for emitting data to the tools. What this really meant was that there was no standardized data format for sending data to observability backends. And on top of that, if a company chose to switch their observability backend, they'd have to re-instrument their code and configure new agents just to be able to admit telemetry data to the new tool of their choice. So there's a lot of work involved here. What OpenTelemetry aimed to do was to provide this standardization. So OpenTelemetry is really a high quality, ubiquitous and portable telemetry, and it enables effective observability. What it is really a collection of tools, APIs, and SDKs. So it offers a pluggable architecture that enables you to be able to add technology, protocols, and formats easily. It supports open source projects that include things like the metrics format of Prometheus, allowing you to be able to store and query metrics in a variety of different backends. So things like Jaeger, Zipkin, whatever it might be, it's allowing this standardization whilst not dictating which tools you have to use. It's compatible with lots of different versions. Now, the one thing to note is that OpenTelemetry does not form an entire observability backend. It is there for the instrumentation part, step 1, not steps 2 and 3 that we discussed earlier. So you will need additional tools like Jaeger and Zipkin that can then connect into OpenTelemetry to actually create that end-to-end backend. OpenTelemetry actually, interestingly, came from OpenCensus and OpenTracing. So these originally were standards for enabling telemetry data to be sort of produced and consumed and collected. However, as you can see, from the nature of there being two, there still wasn't really one standard, which was the whole issue in the first place. So OpenTracing and OpenCensus were kind of combined together to produce this one single standard, hence the name standard. There should be one. So we now have this new project called OpenTelemetry, which is it was created in the CNCF in May 2019, and it's now a CNCF incubating project. So it really aims to take the best of both worlds from OpenCensus and OpenTracing to provide us with that single standard for telemetry data. The way that it works looks a little bit like this when we take a look at an application architecture. So here we have sort of our microservices, our shared infrastructure, and any client instrumentation we might have. And we're sending all of this data into this OTel collector. What do I mean by this collector? This is just a vendor-agnostic implementation of how to receive, process, and export that telemetry data. Normally, it's a single binary that can be deployed either as an agent or a gateway. And what it allows us to do is, again, have that single vendor-agnostic implementation to be able to then send that on to whatever observability backends and front ends we might be utilizing. All of that data is sort of encoded and transported and delivered via the OTLP. This is short, we just love acronyms in tech, so you'll see it a lot. This is short for OpenTelemetry Protocol, and this is the specification that describes that encoding, transport, and delivery mechanism of the telemetry data between the different telemetry sources, the intermediate nodes like collectors, and the telemetry backends. So we're using OTLP for all of that communication here, that specification. This diagram is from OpenTelemetry.io, so do go check it out in more detail if you'd like to. The link's at the bottom there. Diving deeper into our OTel collector, how does that actually work? So as I said, this is the vendor-agnostic implementation of how to receive, process, and export that telemetry data. What it allows us to do by having this collector is it removes the need to run and operate and maintain multiple different agents and collectors. So this enables things like improved scalability, and it also supports open source observability data formats, including Jaeger, Prometheus, FluentBit, and lots of others. So it allows us to be able to send it to one or more open source or commercial backends. So having the local collector is usually the default location to which instrumentation libraries then export their telemetry data. So you can see here that actually this collector is enabling us to have that single place in which we're enabling things like batching, retries. You might be wondering, under what circumstances do I really need to use a collector to send the data instead of just having each service send their data directly to the backend? For trying out and just getting started with OpenTelemetry, sending your data directly to a backend is a great way to get value very quickly. In development or in small scale environments, you can get fairly decent results without a collector. However, in general, we would recommend, especially when you're looking at enterprise organizations or even slightly larger application teams, we would recommend using a collector alongside your service because it allows your service to offload data quickly, and then the collector is then in charge and is responsible for handling things like those retries, the batching, any encryption you might need, or even things like sensitive data filtering. So it enables you to abstract that away from your individual services and have that single point at which all of that activity takes place. So enabling you to offload that to the collector. So we would recommend utilizing a collector if you are considering using this in, say, an enterprise or a production application. But again, this is all just a sort of specification. How do we actually make use of it? And for that, we're going to check out microprofile telemetry, which is an implementation or makes use of OpenTelemetry. So what is microprofile telemetry? I already introduced microprofile, that open source community-driven specification. And within it, in the latest major release, which was microprofile 6, telemetry was introduced for the first time. This adopts OpenTelemetry tracing. Now, this is one thing to mention here, is that at the moment, microprofile telemetry only adopts the tracing element within OpenTelemetry. OpenTelemetry also has OpenTelemetry metrics and OpenTelemetry logging. However, these haven't yet been adopted within the microprofile specification due to things like there's some complications because we already have microprofile metrics. So that is currently being worked out. There are open issues in this open source community on that. So if you are interested, do check them out. But it is hoped that in the future, these will be included and incorporated into microprofile as well. But right now, it's just the tracing element, which is what we're going to focus on today. What this offers is, again, a set of APIs, SDKs, tooling, and integrations, and it is designed for the creation and management of telemetry data. So how do we implement microprofile? Please excuse me, I'm just getting over a cold. So we have 3 different types of instrumentation: automatic, manual, and agent. So for automatic instrumentation, if you're already making use of things like Jakarta RESTful Web Services and microprofile REST client, you can automatically enlist those in distributed tracing already. So it's super quick and easy to do if you're already making use of these specifications. Excuse me. We've also got manual instrumentation. So if, for example, you're not making use of those, or you want to enable tracing in other services that aren't making use of them, then you can manually instrument it using annotations. Now, if you're already familiar with microprofile, you'll already be familiar with annotations because it's how many of the APIs work within this specification. We've got the annotations @with span, or you can utilize CDI injection, so another API from microprofile, to be able to use the @inject tracer or @inject span, or you can also use programmatic lookup. So lots of different ways to enable manual instrumentation. And then we have agent instrumentation. You can use the OpenTelemetry Java instrumentation project to then gather telemetry data without having to make any code modifications. So what it looks like when we take a look at an application architecture is a bit like this. So we've got 2 microservices here that are running using OpenLiberty. And what we're doing is we're sending in requests and we're getting responses back. And we're basically able to trace those sort of requests through our applications using this tracing data and these spans. We're then sending them to that backend exporter because remember, OpenTelemetry and microprofile telemetry is not an end-to-end solution. We still need to send it to an exporter for steps 2 and then 3. And so in this case, we could use Zipkin, we could use Jaeger, we could just use OTLP if we want to. And then in some way, we're going to check out a UI or a log to be able to see that information. So here is where we're going to be able to really understand and gain insight into the requests and responses and the spans that are occurring within our application. So without further ado, I'm going to go into a demo of this to really showcase how this works. Just check that it's up and running. Yeah. So I got it prepared ahead of time just to save time on that. So for this demo, we're going to be making use of OpenLiberty. I mentioned this one already, and this is an open source, really modular runtime. It is lightweight, so it really is designed with the cloud in mind, and it enables you, because of its modular nature, to be able to plug and play the different elements that you need, but not have any more than that, so it's unnecessarily big. Excuse me. So it really allows you as developers to focus on code and to make very fast and iterative changes. And it makes it easy to write tests. And you can also use things like true to production testing, like test containers. So if you are interested in that, do check that out. We have a guide on that. And it's all ready for containers. And as I said, not in your way tools and flexibility. If you'd like to know more about why developers love cloud native, or cloud native developers love liberty, then do check out the article that I've written at the bottom here. It lists out some key reasons why liberty is well suited to cloud native Java development. And I would recommend you checking those out to really understand what liberty can give you, especially in regards to the cloud native sort of modernization and the cloud native world. For this guide, we're going to be making use of our interactive guides. Now, we've worked really hard on these, so we'd really appreciate your feedback. And if you try them out, let us know what you think. They're available from the OpenLiberty website, which is openliberty.io, and in the guide section, so /guides. In this case, I've taken a screenshot of the observability guides that we have, but we do have over, I think it's like 65 guides on loads of different technologies, tools, and specifications. So we actually have one on most of the Jakarta EE and microprofile specs. So if you are interested in any that I'm not covering within this presentation, then do feel free to go ahead and check them out in your own time. You'll notice that many of them have this button that says Run in Cloud. And these are the guides that we enable in our cloud native environment. So for that, you don't need any prerequisites. You just need a browser. And then you can access our labs to be able to sort of try out these technologies. So when you go into the cloud native environment, you'll see a screen that looks a bit like this. So we base this is loosely based on the open source IDE Thea. The IDE will be on the right-hand side. You'll have the instructions on the left-hand side, including any code changes and commands that you'll need. And then you'll have the terminal on the bottom right at the bottom here. So I'm just going to switch into that environment now. So to get here, I went to the OpenLiberty website, which you can see here. You can either search for the guide or you can use the menu here. I'm just going to move my screen a little bit. So in this case, I went to observability. And for this particular demo, we're using this second guide in. So enabling distributed tracing with OpenTelemetry and Jaeger. So in this case, our backend exporter is Jaeger, but as I said, lots of choice. You could use Zipkin if you wanted to. When you go into it, what you'll see is a page like this. This is actually to run it locally. So if you choose to run it locally, that's totally fine as well. But do bear in mind that you will need these prerequisites on your local machine. We do make that clear at the top of each of our guides. The way that the local host, the local guide works is you'll have the instructions here, and then the code will pop up on the right as and when you need it within the instructions. So fairly easy to follow, but we can follow the same instructions within our cloud native environment. Now I've tried to make sure that the screen is big, so please do let us know if if the font's not big enough, and I can try and make it bigger. I can see some of your comments, so do let me know, and I will look in the comments and make it bigger. So on this, in fact, I'm going to go back to the first page. So here we have the first page, which basically gives you some insight into what we're trying to do within this guide. If I say next, the next thing we're going to do is look at, okay, what we're going to learn, but I've already kind of gone through that within my presentation. In this case, we do have 2 microservices. So this application is relatively simple, just to enable you to not have to try and comprehend and understand a very complex system. Instead, we can just focus on learning the technology that we're actually trying to make use of within this presentation. So in this case, our 2 microservices are the system and the inventory microservice. We try and use the same 2 microservices in all of our guides. So if you're doing multiple, then you should start to recognize the architecture we're using. The system just basically scrapes your system every 15 seconds for system data, and it's able to send that through to the inventory, which has a list of all of your systems and sort of, like what that most relevant data is. It's just got a list of them. So we're going to be running these. They're both running on OpenLiberty instances, and you can see that we're trying to gain information from them through OpenTelemetry. In this case, we're using microprofile telemetry for that. So I've already done these 2 steps just to, in the interest of time, save time here. So all I've done is git cloned and cd into the right directory. So all of this is open source. So if you do want to go and check it out on GitHub, feel free. All the code is available. So if I go into my Explorer view, you'll see my project that's in here. And you'll see I have a finish directory and a start directory. All of our guides have these 2 directories in the directory structure. The finish directory is really what you should achieve after all of the instructions in this lab. So it can be a really great place to refer back to if you get stuck, or you introduce a bug of some kind, or you just want to find out where we should get to at the very end. In many of our guides, we do tell you to try what you build and do go to the finish directory first. But in the interest of time, I'm just going to be starting at the start directory, which is where you should start to then follow all the instructions and learn this technology. However, before I go to the start directory, I do need to make sure I do the following Docker command. Now, the nice thing in our environment is that you can basically automate these commands. So either I could use this button on the right-hand side that's for copy, so I can manually copy and paste it across, or even easier is I can use the execute button. So that will automatically execute it in the terminal I have open. If a terminal is not open when you open this environment, all you need to do is go to the top menu here and select terminal and then new terminal, and one will usually appear in the bottom right. It is customizable though, so you can change the layout of this if you want to. Great. So now that that's up and running, I'm going to visit the Jaeger service just to make sure that that backend is up and running for me to use. Perfect. Yep. So that's up and running, so I know that I can continue with the lab now. So just make sure you do that step if you're following this lab, but you don't have to necessarily look at the finished directory if you go through this. So I'm going to skip all of that, and I'm going to go straight to the next page where we're going to start in the start directory. So in this case, I'm just going to cd into that start directory. I'm just going to close that box. And I'm going to start with Maven. I'm going to start Liberty in dev mode. Now, dev mode is a feature within Liberty which allows us to be able to have sort of instant feedback from the code and configuration changes we're making. So it's a sort of like hot reload function. So our server is able to listen out for changes in our code and configuration files and is able to automatically recompile those specific classes rather than having to tear down my whole application and restart it up again. So a really great way to get feedback quickly, especially when I'm developing in an agile manner. So we're going to be using Maven in this case. You don't have to use Maven if you don't want to. We also enable it through Gradle. So if you have a particular preference, you can choose either Maven or Gradle. In the interest of keeping our guides consistent and easy to use and learn, we've kept them all as Maven, just so people don't keep having to switch between different build tools. So you'll notice that all the instructions utilize Maven in that sense. Okay, so as I've been talking, you've been seeing this terminal sort of scroll through. So if I just make this a little bit bigger, we know that Liberty is ready to go, that our application is up and running when we see this message with a line of stars and Liberty is running in dev mode. Now, because my server is having to constantly listen out for changes to my configuration and code, that's essentially taking up that whole terminal. So I'm going to need to open a new terminal if I want to do anything else. So I'm going to go terminal, new terminal, and open up a new one, like I said. So far, I've enabled the system microservice to be up and running. Now I need to do the same for the inventory microservice. So again, I'm going to cd into that right directory, which is essentially, you can either do it manually, or we do give you the whole sort of path that you need to go to. So in this case, we're going in here, into start, and then into inventory. I close my Explorer. And again, we're running this in using Liberty dev mode, so we can have that hot reload, that agile development. And again, we're running this with Maven. Again, we should see this line of stars and Liberty is running in dev mode when we get our application up and running. As I mentioned, this gives you a bit of info on dev mode. So it holds our command line session to listen for those changes. So it does tell you'll need to open another command line to continue. Great, so we can now see that. So you can see it didn't really take too long to get both microservices up and running. So now what I'm going to do is create a new terminal so I can do these curl commands. So I'm going to do this first one, which essentially is going to find the system service by running this curl command. Perfect. So you can see lots of that system data that I told you the system microservice is collecting every 15 seconds. And then we can do the same for the inventory service by running this curl command. So again, you can use that execute, or you can use the, so at the moment it doesn't have any because we haven't sent that through because it's not been 15 seconds. But yeah, you can use either the execute command or the copy and paste. So now that we have our application up and running, we've got Jaeger running in the background, we've done all the setup we need to do to actually get started learning this technology. So to enable telemetry, the first thing we're going to do is do the automated implementation that I talked about. Remember, automated, manual, and agent were the three different types of implementation. So to do this, we're going to navigate to the start directory. So let's just check where I am. Cool. Perfect. So we're going to cd into there. Yeah, great. And then we're going to cd into, oh, I've gone out. Let me just double check that. Okay. So I'm going to cd into, I think I've gone too far now. Yeah, I have. Let's just check that I'm going right to the right place. Perfect. There we go. Okay, back to these instructions. So we're going to go to in this case, we're going to open up the server.xml file to be able to replace the server.xml for the system service firstly. So again, we've got these useful buttons. Either you can do it via the Explorer or you can just use these buttons to be able to open them up. So I'm just going to clear this so it's easier to see and then take this down. We've provided all the code you need, so you can just copy and paste it over, select everything, paste and save. So in this, what you can see is we're making sure that we've added in this feature for microprofile telemetry. You need to add in the various different features you want from the microprofile specification into things like your server.xml so that we can enable that within our system service. We also need to do the same for the inventory microservice. So again, I'm just going to copy across all of that information, and this is for the inventory microservice. So you can see that feature enabled here as well. Kind of weirdly, by default, microprofile tracing is turned off. So to enable tracing aspects, we need to specify the OTel properties in the microprofile configuration file. So in this case, we're using microprofile config to enable us to have an external configuration file external to the main sort of code classes that we have. So in order to do that, we're just going to utilize check I'm in the right place. Yep, start. Perfect. I'm just going to utilize this touch command, and that basically enables me to create that class in the right place. And then I'm going to open it up. It'll be empty because I've only just created it, but I'm going to copy and paste it in these properties into this config file. So as you can see here, we've got two properties. The first is the service name. So that's just referring to what system service we're enabling. So in this case, system, not inventory. You'll notice the change in the next one. And in this case, we need to set the otel.sdk.disabled to false so that it's not turned off, so that it's turned on. It's a little bit backwards, so it's just something to bear in mind with this. The next thing we need to do is create the same, but this time for the inventory service. So then we're going to open this up. Again, it'll be empty when we first do it because we've just created it, and copy and paste this in. You'll see the only thing that's changed is this name. All the rest are the same. So now we've done that for that, we can now run this curl command to be able to essentially enable our two different to basically create a trace through our different microservices. Now we should, as easy as that, be able to actually see already some instrumentation, some tracing data from our application. So if we go out to our Jaeger UI, I can close this other one for just now, and then find traces. You can see I've already got two spans in my inventory service that I can see, and if I click on them, I can get more information about them. So without any code changes already, I can already see tracing data using microprofile tracing in my application because I'm utilizing Jakarta RESTful and microprofile REST client. So you can see that literally within the space of a few minutes, I've been able to get up and running with this fairly quickly. Now, the next parts of these guides, I'm not going to have time to go through today, but you can go through in your own pace. As I said, all freely available on the OpenTelemetry website. So the next part is enabling it through manual instrumentation with those annotations I talked about. So in this case, we're enabling it through things like with span annotation, and you can see it enabled within our application. Further down, just get to it. Yeah, here we go. So it's enabled within here. So we've got the with span annotation that we're making use of to manually add in the spans where and as we want them within our classes to be able to give us that greater granularity of insight into how our application is behaving. So if you do want to have a go with manual instrumentation, check out the next page. And we also go through injecting a custom tracer object as well. And then if we go to the next page, we also run the tests as well, just to make sure our application is behaving as we expect it to. Do bear in mind with this environment that we do save, you'll need to manually save your progress. But if you try and go to another guide, everything from the previous guide will be there unless you clean up your environment. And that will muck up if you do multiple guides in one session. If you log out, it will clear your session. So you can just log out and log back in if you want to do multiple guides. You will need to log in to use this online environment. Unfortunately, we had to add a login because Bitcoin miners got a hold of it, and unfortunately, we're using it. So we've had to add a login, but we've added lots of different social logins. And if you're a developer, hopefully you're using something like, for example, there's options to log in via GitHub or LinkedIn or lots of other social logins. So hopefully there's a login that you can make use of. But do make sure that you're cleaning up your environment after you've done everything within the labs, just to bear that in mind. So going back to my presentation, hopefully what that demo showed is just how quick and easy it can be to get up and running with the telemetry data and tracing and distributed tracing within your application using things like OpenTelemetry and microprofile telemetry as a specification. In summary, hopefully what this whole session has shown is that we are entering a world of increased complexity. And in order to deal with that increased complexity, we need to be building this looking glass, this portal into this world. And effective observability is critical in that to enable us to monitor and understand how applications are behaving and performing in this complex environment. But the nice thing is that it sounds complex and it sounds hard, but there's lots of open source tools and communities out there to help us with it, including standards like OpenTelemetry. And in terms of Java tools, microprofile is a fantastic way in which we can enable that telemetry data. If you fancy some resources, learning more after this session, then do check out the links I provided here. So there's one on what is observability if you want a bit more background information to refer back to. If you want insight into specifically microprofile tracing, I've also created an article there that you can check out. And there is a blog going through the demo that we just went through in the last link there. We are also on social media, so please do connect with us on either LinkedIn or Twitter. I help run them, so I'll say hi if you come and sort of give us a wave, say hi, let us know what you think about the guides. We'd love to know because we do spend a lot of time creating them and hopefully they're useful. So do give us a follow on that if you're interested in learning more about OpenTelemetry or interested in some of the new guides that we're creating around these technologies. So with that, I'm going to say thank you so much. I've left some time for questions, so hopefully I can get round to them at the end now. But if you do have any more, please feel free to reach out on either Twitter or LinkedIn. Thanks so much for listening, guys.
Awesome. Great presentation, Grace. Thank you so much.
You.
It was lovely to hear you. I think you broke our curves, Grace. So you do have some questions for you if you don't mind.
Great.
Sharing them here on the screen.
Yeah.
The first one is from Anna, and she said, "Thank you for the great talk."
Thanks. How does effective observability impact the security posture of cloud-native applications, and are there any considerations to keep in mind? Great questions. Absolutely great questions. So, effective observability is all about enabling a way in which for you to access how your application is behaving in real time. Now, depending on how you implement that observability and how you're visualizing it and how you're accessing it will depend on whether it impacts your security, for example. I'm not going to say you should be broadcasting all of your observability to everyone in the public domain. Probably not the best place to be putting that information. But if you're utilizing backend tools like, for example, enabling things like Zipkin or Jaeger, and you're sending that to a backend tool like Prometheus or Grafana, all of that should involve authentication and authorization in terms of who should be accessing that, how they're able to access it. So not everyone should have access to that data. And these tools are built in a way that has security in mind so that other people can't necessarily just go and access your observability data. So that's why I'd suggest, once you've implemented your code, then it's about utilizing the right tools for you to enable steps 2 and 3 for that sending and exporting the data and visualization and interpretation. But they already have security policies inbuilt to enable you to ensure that it's secure. Hopefully that answered your question.
Yeah, awesome. Thank you, Grace. So thank you so much, and thank you, Anna, for your question as well. We have also some people asking if it's possible to share the links you mentioned in your previous slide also in the comments, maybe for people to later on be able to check.
I'll also share my slides, so if anyone wants to access those, I'll share them on Twitter, and Beatrice, I'll probably also send it to you to be able to share on the chat if I can't, for example.
Awesome. Sounds great. Thank you so much.
Great.
We also have another question from another Anna.
Okay, great. Many Annas. I love it.
Many Annas.
Perfect. So if you mentioned what are the key metrics in telemetry data that should be prioritized for monitoring in a cloud-native architecture, how can they contribute to better? Okay. So the metrics that you want to collect, I would say, are very specific to your application because you might value certain elements of an application more than others. To give an example, if I was building an application for a health scenario where it's very important for that application to always be up and running, I'll probably value health of my application above performance, because I'm going to want that application always there. And if it's not, if it's performing slightly slower, that's okay as long as it's still up and running. So I'll probably value things like health data over things like how much throughput am I getting through my application. If, on the other hand, I'm designing an application that needs lightning fast reaction time, like, for example, the stock market or whatever, something that really needs to change and be have fast throughput, fast performance, but it could, maybe not a stock market in this case, but maybe it can go down and it doesn't matter so much, then I might be prioritizing performance metrics in that regard and not worry so much about the health of my application. So really, it's up to you as an organization, as a team, to determine what's important to you and collect the relevant metrics and information. There's a whole plethora of different metrics that we can collect together that can be collated to be able to give us insight into our applications. Some from MicroProfile. If you check out the MicroProfile documentation, there's two different APIs. There's health and metrics to check out. So health is literally just is it up, is it down? And you set the requirements for that. Metrics gives you much more detailed insight into the individual parts of the application and performance. It's got a whole list in the documentation of what you can enable through MicroProfile metrics. So I'd suggest going and checking that out. And again, deciding what's important for your specific use case.
Awesome. Thank you.
Yeah,
and
of course,
we
yeah.
actually have another question from the same Anna.
Oh,
and
great.
It's a more futuristic question.
Yep. Where do you see the future of observability headed, especially in the context of evolving cloud-native technologies? So it's interesting that you say that, because I've been looking into things like internal developer platforms and things like platform engineering. So it's interesting in my mind, looking at observability from that perspective in terms of enabling a whole new way in which we can gain insight into not just how our applications are behaving or the infrastructure, but how our developers are interacting with the actual development of those applications, as well as the end users. So I see in the future a lot more data coming, not just from the use of it, but from how we build it, that can then influence how we enable development in the future as an organization, and where we collect data from in terms of sources. So I think it's going to be really interesting to see how those two components play out and integrate together to enable us to gain insights into how our applications are designed, developed, and used all together. So I think it's going to be a really interesting crossroads of different communities and sort of methodologies coming all together in once.
Awesome. Thank you, Grace. Thank you for sharing. It's also always very great to think about the future when we're talking about technologies. Grace, I don't think we have any more questions, but it was a great talk. Grace, thank you so much for joining us. And I hope everyone that was watching enjoyed as well.
Thanks so much, guys. It's been a pleasure to join.
So everyone, I hoped once again that you guys enjoyed our call today and you learned a lot with Grace. I hope to see you all in our next live stream that will happen next month. It will be the last of the year. I hope you are all as excited as I am for that one. And it's great. It will be great to have a year in review of more YouTube live streams. Thank you so much for joining us and have a great week ahead. Bye-bye, everyone.